Ladies and gentlemen, today we are talking about standard form and graphing in standard form. What you need to do first is on page 74, exploration, number 1. Those of you talking when I'm talking, that's not good for you guys as a class as a whole. If I have to assign seats, remember, because there's just not too many empty seats in a 30-person class. Okay? Stay focused. We're going to do all this right here. Exploration number 1. I want you to work with your groupie. Off you go on it. So part A goes to Cassie and her group. Or actually the top part. We'll just fill in the boxes. That's Cassie's part. Okay, part B, or part A now goes to Bailey and his group. Part A. When's participated today?
I don't know what to do. Let's just do that.
Okay. Part B goes to Tyler and his group. Which part's the graphing part?
C.
Okay, so we're gonna pause after part B. So Tyler and his group, and then we'll pause. Just using our random number table. Guys, come on. What? No. Alright, that means you guys get to be our experts when I go through it then, because we'll be calling on us all the time. Alright, let's check it out. This first part, 4 per adult. Cassie, Daisha, she wrote them up, so you got to get the answers here. How did she get 4? Yeah, it's $4 per adult, right? So in this problem, an adult ticket's worth 4. A child ticket is worth 2, and we can spend a total of 16. This is called a total value problem. Okay? Usually story problems can be broken up into total number, total value, or comparisons. This is a total value. It's assigning a value to your variables. And using x as adults, y as childs, 4x plus 2y equals 16. Very good. So that becomes x, that becomes y. Well done. Who did part A? Bailey?
Yeah.
Nice job. All right. So Tyler and Mr. Gunner back there. You guys ready? Not exactly. Give me a value for x, Gunner. Yep. No, we can't put what in there. That doesn't input really well. Oh, give me a value for x. 3. Okay, so we put 3 in. I input it right here. Ty, what do I get there? 12. And, we got 2 y's equals 16. All right, so Gunner, we have 12 plus 2y equals 16. That gives me 2y equals what, Gunner? 4. And y is? 2. 3, 2. Okay. So what inputs do we use? Some of you are confused. What inputs? You pick the inputs. Okay. I would say that the way I kind of did random abstract scratch work on my paper is not the best, most efficient way. I would just put x and y and use my H table, right, Gunner? Gunner, what's your last name? Oh, dude, H table, right? See? Like maybe named after you never know. Okay. All right, now the problem with this, if we're trying to do an input-output table like this, we've usually had one of our variables by itself. We've usually had y by itself. Here we don't have y by itself. Okay? So if you're going to do a table like this, which is really helpful, it's nice if you put y, get y alone first. And we did that earlier in the year. So if I took 4x plus 2y equals 16, and I solve for y, I'm going to subtract 4x, I get 2y equals negative 4x plus 16, and then divide by 2. When I divide by 2, I divide everything by 2. I divide that by 2 and that by 2. Yep, I could. Negative 2x plus 8. And now I can put this chunk in right here, because now I have an input-output table. Okay? I've got 3. We already know. Gunnar told us negative 2 times 3 plus 8. That is negative 6 plus 8, or 2. What's another value I could use? 1. Negative 2 times 1 plus 8. Negative 2 plus 8 is Jason. You can't sit by him without distracting someone. You will not be in my class. Okay? Pay attention. Negative 2 plus 8 is? 6. Way to step up and be the man. 0. Negative 2 times 0 is? Plus 8? All right, so there. Hey, we've got some values here. We have enough? No, we already got 3. How many more we need? I need some other values, so give me some values. 2. What is 2? 4. Give me another one. 4. What is 4? 0. Now, what's wrong with this table? It'd be nice to be in order, right? It's like in messed up order right now. So usually we should have a plan when we're doing a table. We shouldn't just go random abstract. Some of us do that, okay? So if I start at my lowest number here, I started with was 0, 0, 8, 1, 6, 2, 4, 3, 2, 4, 0. And that makes it easy now. You see the linear pattern. Okay, the 2 things I want to focus on are these 2 numbers right here. That one and that one. I want you to write the ordered pairs represented by those 2 sets. All right? What are ordered pairs here? What's this one? 0, 8. What's this one? 4, 0. Okay, this right here, when I plot 0, 8, everyone plot it on your graph, even if you've already done it. Hopefully it's lying on the line that you want. Okay, when I plot 0, 8, that puts me right here. What do we call that point?
Y-intercept.
It's called our y-intercept, right, Logan? Yeah, y-intercept. Okay, x, when I plot this one, what's that one called?
X-intercept.
Yes, thank you, x. But x? Yeah, I know, I couldn't hear you. Sarah was helping us out there. Good job, Sarah. Okay, so we have the y-intercept and the x-intercept, and when I draw a line, how many points do you need to make a line? 2 points. 2 points make a line. I draw a line, and kerchow, I got it. That's my line. Now, my question becomes, we've done a lot of different info this chapter where we've talked about discrete and continuous, and some of you guys seriously grading your quiz, some of you still don't know. Okay? Hands down for a minute. Relax. I know. Relax. Okay? We're looking at this. We've got 1, 6. That's that point. We've got 2, 4. That happens to be that point. We've got 3, 2. That happens to be that point. Now, all those with their hands up, what was wrong with this? Why is it discrete? Okay. This is a ticket. That represents tickets. This represents, this by the way is, this is how, what type of tickets? Adult tickets. Okay, this is what?
Children tickets.
Student tickets or child tickets. Okay? All right. So we have to erase all this stuff in between because you can't have partial tickets. All right.
Oh, you can't sell partial tickets.
Very good. Well, yeah, I guess you could tear them apart.
But you
All right.
can't sell them that way.
You can't sell them.
Yeah,
Okay. Hey, I wanna go ahead and move on here. Why don't you guys go on exploration 2? Work with your groupie. I'll call some of you up to do. Okay, ladies and gentlemen, I'm gonna pause for a minute. Very good. Kellen, you got anything right here we can use? 8? Good. So 8 pounds. So it's like actually $8 per pound, right? Okay. And we're calling Swiss cheese, everyone? X, so that would be 8X, right? And what do we got per pound of rant or cheddar? 6, and we're calling cheddar y. So Jillian, what do we call this? 6y. That's y. Okay. And Aaron, what do we got right here? 48. That's our total cost. All right. Now, you guys looking at 8, 6, and 48, notice all three terms, 1, 2, 3. Kai, what goes into all three of those? What number? Nah, it goes into that one and that one. I just made that mistake mentally also, yeah. I could divide this whole thing. You guys, you know about reducing fractions. You can also reduce equations. Okay, you can reduce equations to make them easier if you want by dividing out a common factor of all parts. It has to be in all parts, though. So 2 goes into each of those. So if we wanted to, we could actually write this. If we divide everything by 2 or multiply it by a half. Okay, this becomes 4x. This becomes, and this becomes 24. Just some easier numbers to deal with now. Smaller numbers. Okay? Do you have to? You don't have to. But it makes it smaller numbers, which we like. And now if I'm solving for y, what's the first thing I want to get rid of? I want to move the 4x. Okay, when I subtract 4x from both sides, Logan, what do I get? What am I left with here? Okay, I'm left with 0x and how many y's? Just 3y, right? On this side? 3y and 24 minus 4x. How do we write that?
24 minus 4x.
Good. We will write it as negative 4x plus 24. You can't put them together. So Cassie, if I want to get rid of the 3, how do I do that here? Divide by 3. 3y divided by 3, Tyler, what do we get? 3y divided by 3? 1y. That's y. Okay. And then negative 4x divided by 3 is?
1 1/3.
Okay, or just negative 4 over 3. Let's leave it like that. Okay. And then 24 divided by 3 is what, Brian? Yep. 24 divided by 3? So ask yourself what times 3 makes 24? Yep, that's true. It is 8. Okay, now the benefit of having it like this, a couple reasons. Last problem we talked about our input-output table. So those of you taking this in, I promise you, as you progress in math's going to be a lot easier. And you may actually get to a point where you're like, if you're not already there, because most of you probably should be, you'd be like, I love math, dude. It's like my easiest subject. Okay? But if you have a graphing calculator, go ahead and take it out now. If you don't have one, you should come over and borrow one quickly. So we've got our graphing calculator. In order to reset our memory so that we're all at the same place, going to second plus, and then 7, option 1, and then 2. Second plus 7, 1, 2. Okay, and it clears your RAM. That puts everyone at the same starting place. Okay, now if we go to y equals, okay, the benefit of having an equation in y equals form is you can use your graphing calculator. You can also make your cool table. Okay, we can put in negative 4/3 x plus 8. So negative 4/3 x, a lot of students go, well, how do you put your fraction in? Well, there's actually a way to put your fraction in, but you could also, if you want, you could also just go 4 divided by 3. You don't actually have to put it in like the fraction, use a fraction button. 4 divided by 3, but mine should be what? Should have been negative 4, so I got to go back over here. I'm going to go now negative. Now when I use negative, it's not the minus sign. Okay, it's not that symbol. It is the negative symbol. Okay? Let's see if I can make that a little less bright for you guys. Not so much. That's all right. Okay? So I'm going to go negative 4 divided by 3. Like that. Okay? Negative 4/3, and then my X button is right here. I know there are a lot of different X's. We want this one right there. Okay? So it's this x. It says xt theta n. And then you're going to do plus 8. And then if you push the graph, these 5 buttons up here, they control your graphing stuff. So if I hit graph, you'll see a line appear. There it is.
Oh yeah, I did it right.
Oh, what? Yeah.
So crazy.
Okay.
Magic.
Now, there's a few cool things about this. First, you can actually graph, but another cool thing, what does it say above graph?
Table.
Table. And how do you access that?
That's F5.
Second graph is table. And there's your table. And here's what I want you to do in your table. Just because last, now notice you can move it up or down.
What does F5 do?
What I would like you to do is find your x-intercept and your y-intercept in the table, please. Find the x and y-intercepts in your table. Write them down. That's part C. Let me try to darken this display a bit. Whoa, that's really dark.
Second. Okay.
Okay. What is my x-intercept? X-intercept is when y is what?
0.
0. So what is the x-intercept?
6.
It's 6. Okay. If I go to where y is 0, that's right here. That's 6. So what coordinate is that?
0, 6. No,
Oh, I've lost you guys. So we're about done? We're good?
6, 0.
6, 0? Okay. Y-intercept. What's the y-intercept?
0, 8.
0, 8. Okay. It's where 8 is. Okay, it's where 0 is for x. All right. Now, how is that beneficial to us? Well, when we graph it, everyone go back to your graph. When we graph it, I want you to find the x-intercept on this graph. Where it crosses the x-axis. What point is that? That is 6. Okay? Okay, find your y-intercept on the graph. What is it? It's 8. Okay, that's the same thing you have for your x and y-intercepts. If you were to just plot this point and that point, you'd be able to draw your line through it. Now, does it make sense in this problem to have a line? Is this continuous? X stands for pounds of Swiss. Tell your neighbor why it may be continuous or why you think it is not continuous.
I think it's continuous. You can eat a fraction of a piece of cheese. And you can have...
Okay, time's up. Volunteer. Continuous? Jillian? Good. It's continuous on X because you have a fraction of the pound, and same thing happens on Y. Okay. Very good. I want you guys to take a look at page 77 of your student journal. Find page 77. Hey, man. Eyes up here. Page 77. Go ahead and graph number 1 and number 2. Okay, can I have your attention, please? I want you to tell your neighbor how many axes. What's an axis, by the way? You have X and Y. Everyone show me axes with your arm quickly. X and Y, right? Right here. Okay?
Oh, just X and Y.
All right. Yeah. Make sure you're not being rude and disrespectful with it. Okay? So, Y equals -3. All right? I want you to tell your neighbor how many axes you cross over.
I believe we cross over 1.
Okay, everyone on your fingers, 1, 2, or 3.
3 minus 2.
Okay, if you have 3, that's really bad because there's only 2 axes. Okay? Hey, it is 1 axis. Which axis are you crossing over?
Y.
You're crossing over Y. Why?
Because no matter what X is, it's always Y equals -3.
Okay, let's make it even simpler. If it says Y equals and you don't see an X, you only cross the Y axis. So something to add to your notes, you're crossing at -3. That is the only axis you will cross, and you will cross at -3.
Wait, doesn't it go all the way?
No,
Nope.
it's a straight line. Y is always -3.
Okay, with that being said, I want you to make sure number 2 is correct. Same rules apply with number 2. Okay, now tell your neighbor how many axes you cross on number 2.
1.
Okay, on your fingers.
3 minus 2.
Yes. Okay, and it is? 1. Which axis?
X.
X. Cross right here. Therefore, when there is one variable in your equation, you only cross one axis. Unless that variable says it equals what number? Which number will you automatically cross both?
0.
0. Okay. All right, something to add to your notes there. It's important stuff. Okay, I want you to take a look at page 78. 78. Take a look at number 6 and number 7. We'll go back to 4 and 5, 3, 4, and 5. But number 6, use the intercepts to graph the linear equation, then label the corresponding points of the intercepts. Actually, you know what? We better start with number 3. That might be easier. We might want to start here. Okay, this guy right here, 3x plus 4y equals 12. If I want to find the x-intercept, that means I have to cross the which axis? X-axis. X-intercept crosses the x-axis. Okay? If I'm crossing the x-axis somewhere right here on this line, what does y have to equal?
0.
Y is going to equal 0. So to find the x-intercept, I need to plug what in for y? 0. And when I plug 0 in for y, what happens to this piece of my equation? It goes away. It becomes 0. So really I'm asking myself the question, 3x equals 12. 3 times what is 12? 4. So my x-intercept is 4. The x-intercept equals 4. Now how do we write that? You can write it like that, but it's also a coordinate. It's 4, 0. Go ahead and figure out what your y-intercept is. Okay, let's see if you got it. Y-intercept is when x is? It's when x is 0. So if I plug 0 in for x, what happens to the 3x part of the equation? Goes away. So 4 times what is 12? 3. So my y-intercept is 3. What is the coordinate for that? You guys good? 0, 3. All right. So if you're using equations, just plug zeros in. That'll help you find the intercepts. What I want you to do right here on number 6, I want you to graph that one now. Okay, use your intercepts. Find the intercepts, plot them, and graph it. Okay, guys, it really is as simple as saying, hey, x-intercepts are when y is 0, so just cover up the y. Negative 8 times what's 24?
-3.
-3, so x equals -3. Okay, y-intercept is when x is 0, so cover up the x. 12 times what is 24? 2. Y equals 2. You plot the 2, you plot the -3, you draw your cool guy line, and then you are done. That is quicker than making a table. There, got it. I get it too. All right, I'll be walking around. If you need help, let me know. Otherwise, try number 7. Maybe. Okay, number 7. Let's make sure we're clear. X-intercept. Cover up the y. We get x equals 2. So, y-intercept. Cover up the x. Sergi, what do I get? You're not Sergi? Yes? Yeah, it does. It is 4. Vincent, thank you. Okay. So we go to x equals 2, y equals 4. We put our dots. Remember, this is not slope. It's intercepts. Crosses the x and y axis. All right? So those of you thinking, why aren't I putting a dot right there? It's because we're not using slope. And voila. There we go. All right. Everyone rate themselves 1 to 5. 5, you got it? 1, you're struggling? I'll be around to help out if you need it. Okay, your assignment is practice A. That's what I just handed out to you. There you go.
You did?
Woohoo!